हेलो स्टूडेंट्स, वेलकम टू फिजिक्स वाला गेट वाला। कैसे हैं आप लोग? सो आई होप योर प्रिपरेशन इज गोइंग एब्सोल्युटली फाइन। सो आई होप योर प्रिपरेशन इज गोइंग एब्सोल्युटली Please just let me know whether audio, video, everything is fine. Please just let audio, video, everything is fine. Hello everyone. How are you? Fine. So let's start the session. So in last class, we discussed about what is basically thermodynamics, how to study it. So there are two methods to study thermodynamics. One is microscopic viewpoint and another one is macroscopic viewpoint. To apply the macroscopic viewpoint, there is one criteria. That criteria is concept of continuum. So we already discussed what is this concept of continuum. Now in this class, we are going to talk about the thermodynamic property. Like in last classes, whatever concepts we discuss may not directly come into the, directly involved in solving the problem. That may be possibility. But those concepts are essential to understand the question itself. Like last class we discussed about what is a system, what is thermodynamic system, like open system, closed system, boundaries, type of interactions, right? So all those things may not directly involved in the solving the problem, but indirectly these concepts you must understand to solve the problem. Clear hai? Okay. So let me start the today's lecture with the concept that is thermodynamic properties. So as like in first topic I told you that we are going to discuss introduction part. That is already done in first lecture, first video. This is covered in the very first lecture, and then after that we discuss about the concept of continuum in our second lecture. Then in third lecture we discuss about the system, surrounding and boundary. Now today is the fourth lecture, right, where we are going to talk about the thermodynamic properties, right? So these are the four things we up to now discussed. If you did not gone through the previous lectures like introduction part, concept, continuum part, system, surrounding, boundary part, so I'll suggest you after completing this class you can go and watch those lectures. Even it is better to go and watch those lectures first and then come and understand what is this thermodynamic property. So let me ask you one question. What is a property? I'm not talking about thermodynamic. I just want to know what is basically a property. What is basically a property? Anyone? What is basically a property? No idea? Okay. Let me ask you one question. Suppose you are standing in a bus stop. This is a bus stop. Here it is written the bus, right? It is a bus stop. Now you are sitting. This is you, right? You. And this is one girl, right? This is one girl, right? You don't know her name, right? You don't know her name. And I know that you are a mechanical engineer, so you don't have guts to ask her name, right? You actually want to know her name. Basically you actually want to know her name, but you don't have guts to ask her name because you are a mechanical engineer, right? So you just seen that girl, right? You just seen that girl and come back to your room. Come back to your room, right? This is you. This is again you. And this is your roommate. This is your roommate. Now you want to tell your roommate that whom you seen in a bus stop. Whom you seen at the bus stop. That is actually the question here. What you will do? You understand my problem? You understand my problem? My problem is very much simple, that you were in a bus stop, right? In bus stop you seen one girl. You want to know her, you want to know about her, you want to know about his name and something, but you don't have guts to ask because you are a mechanical engineer. So simply watch that girl, you just simply see that girl and come back to your room. Now you want to tell about that girl, right? You want to tell about that girl to this friend, but you don't know the name. Then how you will do? Then obviously you are going to tell something, right? You will say maybe that girl is very fair, that girl height is this one, that have a brown eyes, blah 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 blah. Lot of things you will tell. Lot of things you will tell. After some time your friend will say, okay, you are talking about Priyanka. Now my question is, how your friend is actually identifying her? How your friend is actually identifying her? Because you are sharing some of the characteristics about this girl, and those characteristics which help in identifying her, that is called as a property. You are getting my point, right? So property means, in case of thermodynamics, if suppose one thermodynamic system is there and you want to identify the condition of that system, then you need to tell some characteristics, and those characteristics basically known as the properties. So properties are the characteristics by which the system can be identified. Properties are the characteristics by which the system can be identified. Clear hai? Any problem? No problem at all. Now I'm going to share here few things about the properties. The very first thing is the thermodynamic property, right? I'm going to talk about thermodynamic properties. So just now I told that thermodynamic properties are the characteristics by which the system can be identified. Clear hai? And not only a system, the condition of the system can be identified. Right? What is the actual condition at a particular instant, that can be identified with the help of thermodynamic properties. Like suppose I have this mobile, right? I have this mobile. I want to know the condition of this mobile. Then what I would say? I will say whether battery is there or not. What is the temperature? What is the pressure? So similarly, let's say one thermodynamic system is there, and you want to know the condition of that thermodynamic system. Like suppose you are sitting in one room, and in your room some air is there. I want to know the condition of that air. Then obviously you need to tell some properties, like what is the temperature of that room, what is the humidity, right? Whether fan is there or not, bulb is there or not. So whatever properties are there that you need to tell me, then only I can identify the state of the system. Then according to that, I can suggest you that you need to use a 1 ton AC or 2 ton AC or something. So pressure, temperature, volume, these are the characteristics by which you can identify the state of a system, a state of a thermodynamic system. Now these thermodynamic properties can be classified in two ways. One is intensive property, right? One is intensive property. Another one is extensive property. One is intensive property, another one is extensive property. One is intensive property, another one is extensive property. Rajib, correct. Now what is intensive property? Intensive property means independent. Can you tell me? What is intensive property? Intensive property means independent of mass or size of the system. You just remember this word, right? Because many students have confusion which one is independent and which one is dependent. So always remember this word independent of mass or size of the system. I can say here that independent of mass or size of the system. Size of the system. Some of the people thinking that it is intensive property means independent of mass of the system. But our system is not only mass. Our system can be identified, or I told you in thermodynamics only two systems are there. One is quantity of matter means mass, another one region in space means size. So if any property that does not depend upon the mass or the size of the system, then it is called as a intensive property. Can you tell me the some of the example? Please share me the some of the examples. Some of the examples of intensive properties. Please tell me the some of the some of the intensive properties. Please tell me some of the intensive properties. Anyone? Rajib. Intensive properties which are independent of mass or size of the system, like yes, like pressure, temperature, and anything else, density, etc. Pressure, temperature, density, etc. Now dependent property, I can say that extensive property means depends on mass or size of the system. Size of the system. Mass or size of the system. Example is very simple, like mass itself is a property. Mass is there, volume is there. Mass is there, volume is there, and I can say internal energy or energy of the system. Energy of the system. Enthalpy. Entropy, etc. Enthalpy, entropy, etc. These are the basically extensive properties. Now my question is, here I am saying that intensive properties mean independent of mass or size of the system. Independent of mass or the size of the system. Now density is defined as rho is equal to m by v, right? Here I am going to write that density is basically mass by volume. Mass per unit volume means it seems like density is depends upon the mass. It seems like density is depends upon the mass. Please tell me whether density is a intensive property or extensive property. Just tell me once whether it is a intensive property or extensive property, that you need to tell. Density is an intensive property or extensive property? Anyone? Because it seems like directly, if you see, it seems like a density is directly depend upon the mass. But actually but actually density is an intensive property only. Actually density is an intensive property only. It does not depends on the mass or size of the system. Now the question is coming, sir, how to identify? Now question is coming, how to identify whether a system is an intensive, whether a property is an intensive property or extensive property. So whenever you need to check whether a property is intensive or extensive, then what you need to do is you just have to consider one system, maybe a room kind of thing, right? You can consider a room kind of thing. Okay? Now what you need to do is you have to consider one room kind of thing. This is a room. You assume that, suppose this is your room. You are sitting in one room now. That is your room. In that room some air is there. So obviously that air has some mass. That air has some mass. Obviously have some volume, right? Has some energy of the system, like energy of the molecules or internal energy or energy of the system. Some pressure is there, temperature is there, and obviously density is also there. Density means mass per unit volume. These are the properties. So total 6 properties I wrote here, right? सर कल मॉर्निंग से थर्मो स्टार्ट होगा ना? नहीं बेटा, कल से नहीं है, मंडे से है भाई, मंडे से स्टार्ट है ना. कौन सा बैच है आपका? यू आर इन विच बैच? राजश्री रॉय, you are in which batch? I think if you are from Parakram batch, if you are in Parakram C batch, yes. So in Parakram C batch, the thermodynamics is going to start from the Monday morning, either from 7 o'clock or from 8 o'clock. Okay. Now just tell me. See, here I consider 6 property. You can consider somewhat more, no problem. I consider very basic properties which you already know. Now I want to identify out of these 6 property, which one is a intensive property and which one is a extensive property. Whenever you need to identify whether a property is intensive or extensive, then what you need to do is you have to divide your system in 2 parts. You have to divide your system in 2 parts. Now I am going to divide this system in 2 parts, right? Exactly equal parts I am dividing, okay? Now, if you divide in 2 parts, let's talk about the one side only. Let's talk about the one side only. So, what about the mass? Mass will be obviously half. Mass will be obviously half. What about volume? Volume will also be half. Mass is become half. Volume is become half. Energy will also become half only. Energy will also become half only. So energy is also half. But what about pressure? See, half mass will be this side, half mass will be another side. Half volume will be this side, half volume will be another side. Right? Exactly equal I divided and E by 2. Now, what about pressure? Pressure is not going to change. Pressure, both the side pressure is going to be same only. See, you just assume that you are sitting in one room where some mass of the air is there, volume of the air is there, energy of the system is there, and you just have to create one wall in between. When you create one wall, then like one side, if you see, mass will become half, volume will become half, energy will also become half, because energy, this energy is energy of the molecules. If number of molecules will divide, means mass will also energy will also divide. So but pressure will not change. Let's say in your room atmospheric pressure is there. So if you create one wall, both the side atmospheric pressure will be there. Let's say temperature is 40 degrees centigrade. So both the side 40 degree only will be there, right? Means temperature is also going to be the same. But what about the density? Density, if you see, so in this side, mass is m by 2, volume is v by 2. So basically it is m by v only, means it is not changing. So the properties which are not changing, with size, that is called as intensive property, right? That is called as what? Intensive property. And the properties which are depends on the size, that is called as a extensive property. Extensive. extensive property. Is it clear to everyone? Is it clear to everyone? ये बात clear है? Everyone clear that, right? So what I told that, suppose some system is there, you just want to identify whether given properties are intensive and or is extensive, then you have to divide the system in two parts, right? And you just look at the properties. If property value is changing, then it is an extensive property. If property value is not changing, then it is an intensive property. Clear hai? Done? Okay. Now listen here carefully. Density, not only density, beta. See, density is what? You need to understand one thing. Density is what? Density is mass per unit volume. Mass per unit volume. It is not the only property which seems like a intensive. Seems like extensive, but actually it is an intensive. Actually, mass is an extensive property. Please listen here carefully. This mass is basically what? Extensive property, right? And volume is also extensive property. So ratio of two extensive properties always intensive. This is going to be a intensive property. So one very important point that the ratio of two extensive properties is always intensive. Ratio of two extensive properties always intensive. Now some of the students are still in confusion. Sir, how it is possible? Because it seems like rho is directly proportional to m. It seems like, no, right? Some of the students are thinking that rho is equal to m by v. So I can write that rho is directly proportional to m and rho is inversely proportional to 1 by v. Is it correct or wrong? Anyone? Is it correct or wrong? Is it correct or wrong? Actually, it is not correct. If you are taking this conclusion, this is not correct. See, if any function z is there, my dear student friends, right? If any function z is there, that is x by y, so you cannot say that z is directly proportional to x and z is inversely proportional to 1 by y. You cannot say that. You cannot say that. Please, this is a basic mathematics. This is a basic mathematics that if z is given as x by y, then you cannot say always that z is directly proportional to x. Because there may be chance that x and y are dependent with each other. X and y are dependent with each other. Let me give you one example. Let's say z value is 1 by 2. Z value is 1 by 2. Now, if we increase the numerator value, then z value will also increase. It seems like that. If numerator value, if I increase, then z value will increase. It seems like that, but it may not be true, right? It may not be true. Like it is x by y. Let's say x value is 1, y value is 2. X value is 1, y value is 2. Now I am increasing x. Now I am increasing x by 1 unit. Now I am increasing x by 1 unit. So it become 2. Right? But x and y are dependent with each other. So if you increase x, then there may be chance y will also change. Let's say y is actually, when you increase the x value, by 1 unit, then y is going to increase by 3 units. So now y will be automatically 2 plus 3. Now you can see that z value actually decreases. Now it is 2 by 5. Now it is 2 by 5. You are getting my point or not? Please try to understand. If one function is there, that is z is equal to x by y. Please explain Gates benefit. Okay. I will. Just wait for some time. So what I'm trying to say here, that z is basically what? Z is basically proportional to x. Z is basically proportional to x. You can write only if x and y are independent. X and y are independent, then only you can say. Let's say if you are increasing x value but y value is not changing, in that case you can say that z is directly proportional to x. Otherwise you cannot say. This point is clear to everyone. This point is clear to everyone. So here actually m and volume, mass and volume are dependent one. Whenever you are changing the mass, right, then volume is also changing, or you are changing the volume, mass is also changing in most of the cases. Clear hai? Okay. Now one more question mostly asked in the interviews, that let's say you have one piston cylinder arrangement. Please listen here carefully. Please listen here carefully. And here some of the properties are there. Let's say pressure is given as 1 bar. Pressure is given as 1 bar. Right, pressure is which type of property? Sir, intensive property. Pressure is a intensive property. It means that if we change the size of the system, then property will not change. Property will not change. If it is an intensive property, then property will not change. So what I am going to do? I am going to push it. Right, I am going to push it, right? I am going to push it, and the volume is decreased. Now what about the pressure? Pressure will increase or not? Yes sir, pressure is increasing. Now here pressure may be 1.8 bar. Just random value I am taking. So earlier pressure was 1 bar. When I decrease the size, then pressure is increasing. It seems like a pressure is extensive property. Because pressure is dependent upon the size of the system. So listen my dear student friends carefully, that this criteria is only valid when there is no any external interaction. There should be no any heat transfer or mass transfer or work transfer outside from the system. There is no any mass transfer, heat transfer, work transfer from outside the system. Clear? Then only this method is valid. So this method is only valid that you are dividing the system. So whenever you are dividing the system in two parts, then please careful that there should be no any work interaction, heat interaction, mass interaction between system and surrounding. Then only this method is correct. Clear hai? So in this way you cannot judge. Whether it is an intensive property or extensive property. Clear hai everyone? Satyam, CK, Rahul, sir, please go back to academy. Sir, please, thermal Baba. Hare Rahul bhai, past is past. Let's talk about the present and future. Beta. Okay. Now, so here 2 points are clear. 2 points are clear, Rahul, that the ratio of two extensive properties are always intensive. Okay, so this point is clear. Now the next point I want to tell here, that specific properties are extensive property. Right, specific properties are extensive property. Because of you I am in IIT Kharagpur, sir. Now Rahul, congratulations. So you are in which branch? Or course in IIT Kharagpur? So Rahul, if you are in IIT Kharagpur, so one question is there, very good, design. So definitely you will get a good placement in next year. So I just want to ask one question. What is a specific property? Tell me. अरे सर छोड़ो ना यार, गेट खत्म हो गया मेरा. Said gate is over, sir. Why you are asking the same question? What is a specific property? I told you in the class. Right. So specific properties are specific properties are intensive properties. Specific properties are always intensive properties. Right. Okay. So now specific properties are always intensive properties, right? Per unit mass. Very good. So per unit mass, but which one? Extensive property per unit mass. Extensive property per unit mass. Per unit mass. Except one property is there, that is specific gravity. You may study it in fluid mechanics, that is specific gravity. So specific gravity is basically extensive property per unit volume. It is defined per unit volume. All other specific properties are defined per unit mass. All other are defined per unit mass. Very good. Now if we talk about per unit mass, beta, extensive property per unit mass, then how we are going to identify this? See, just now I told that extensive properties are only depend upon the mass. Intensive property do not depend upon the mass. So there is meaningless to talk about per unit mass. Like if you are talking about intensive property per unit mass, then it's a meaningless. You have never seen that someone is talking about a specific pressure. There is no word like a specific pressure or a specific temperature, because it's meaningless. For example, suppose you are sitting in one room where mass value is given 10 kg, right? You are sitting in one room and mass is basically 10 unit, and total energy is 100 kilojoule. So if I calculate specific energy, small e, then it will come E by m. It means that 10 kilojoule per kg. It simply means that suppose if you have 10 kg mass, and out of 10 if you consider only 1 kg, then in 1 kg how much energy will be there? 10 kilojoule per kg energy will be there. In total 10 kg energy is 100 kilojoule. If you just take it out, 1 kg if you take it out, then 10 kilojoule energy will be there. But at the same time, let's say the temperature, mass is still 10 kg. Now temperature is given as a 30 degree. Whole mass have like 10 kg mass is there, and that 10 kg mass is 30 degree. If you take it out 1 kg, if 1 kg will take it out, then will temperature will change? No, temperature will not change. It is meaningless to define T. You cannot define T by M, that is 3 degrees centigrade. No, it's meaningless thing. It's meaningless. It does not have any significance. So that's why we are always defining extensive property per unit mass. Clear hai? Extensive property per unit mass. Now let me tell you one thing, that this is nothing but what the first statement only. This is intensive properties. Now what is specific property? I told specific property means extensive property per unit mass. So listen here, in numerator property is extensive, in denominator also property is extensive. Here also extensive, here also extensive. Mass is also extensive property na. So ratio of two extensive properties are always intensive. It means that it is nothing but what? First point only. It is nothing but what? First point only. Okay. The next very important point, that properties are independent of the past history. Properties are not dependent upon how it is achieved. These are the point function. Suppose in this room temperature is 30 degree, right? Temperature is 30 degree. So whatever hotness or coldness is associated with the 30 degree, that does not mean that how it is achieved. For example, here currently here AC is working, right? But it's still not working perfectly, but okay, fine. Let's say AC is working in this room and the temperature is 20 degree temperature. Now in this room temperature is 20 degrees centigrade. So whatever hotness or coldness associated with 20 degrees centigrade, that does not depends upon that how you are achieving it or what AC you are using. Whether you are using voltage AC or you are using 5-star AC or 3-star AC or Panasonic AC, which AC you are using, that doesn't matter. That doesn't matter. You are getting my point or not? The only thing matter is what? The temperature here. But there are certain properties, certain things which actually depend upon how it is came into the picture. For example, work is there, heat is there. These are the path functions. Let's say you want to find out that how much work is required to attain this 20 degrees centigrade, then you must know that whether AC is a 5-star or 3-star or 2-star. Means what is AC? That you need to know. Clear hai beta this point? Okay. So I can say that the properties are state function or point function. These are not path functions. So whatever property we discuss, whether intensive property or extensive property, whether it is an intensive property or extensive property, these properties do not depend upon the past history. These properties do not depend upon the how it is achieved. These properties are not depend upon the path followed by the system. These properties are only a point function. Clear hai this point? Okay. The next very important point, that properties are exact differentials. Properties are exact, like work is there, heat is there. These are not exact differentials. So you cannot differentiate it. Right, you cannot integrate it, right? This is not possible. Clear na? But properties are exact differential. Sir, what is a condition for exact differential? Let any function z is there. Let z is a function of x and y. Let z is a function of x and y. So I know that you know little bit of calculus. So by Taylor expansion, I can write dz is equal to Taylor expansion. Taylor expansion, you know na? Taylor expansion, dou z by dou x into dx plus dou z by dou y into dy. If any function z is there, and that is a function of x and y, then dz can be written as dou z by dou x into dx plus dou z by dou y into dy. Now what is this basically? This is basically m. I can say that this is basically m. This is basically m. I am writing m, and this I am writing n. So basically I can write dz is equal to m dx plus n dy. So if any function z, that is a function of x and y, can be written in form of dz is equal to m dx plus n dy. How to write? Taylor expansion. And z is said to be exact differential. Z is said to be exact differential. Exact differential. Z is said to be exact differential if dou m by dou y at constant x is equal to dou n by dou x at constant y. This is basically the condition of exact differential. This is condition of exact differential. Now this is very important point, right? This is very important point. Up to now, whatever you studied, my dear student friends, right? Whatever you studied from that, there is no any chance that any direct question will come. Sir, please once tell me where is the Pawan sir. Pawan sir is also very good, right? He is in Lucknow only, right? So properties are basically what? Exact differentials. So this is the condition of exact differential, right? Now, so they used to ask questions. What they will do, they will give some functions to you. Let's say one function is given. Let's say for ideal gas, dz is given as dt by t minus v by t of dp. Now you need to tell whether z is a property or not. Now if I ask you whether z is a property or not, so it's very, very simple. What you need to do is you have to compare. First you have to compare with dz is equal to m dx plus n dy. So m का वैल्यू क्या आएगा? m is 1 by t, dx is dt, n is minus v by t, dy is dp. Now find out dou m by dou I. Dou m by dou I at constant x means dou of 1 by t of dou p at constant t. So this value will come 0. But t is constant here. If t is constant means 1 by t is also constant. Constant ka differentiation 0. Now calculate dou n by dou x. Dou n by dou x at constant y. Dou n by dou x at constant y. So this value will come dou of minus v by t by dou t at constant p. Now here p is constant but v is not constant. If v is a variable, then you cannot differentiate this function in this particular form. So what you can do that for ideal gas, we already know for ideal gas PV is equal to RT, right? PV is equal to RT. So V by T can be written as R by P. V by T can be written as R by P. Just put this value here. So you'll get a dou n by dou x at constant y is equal to dou of minus R by P by dou t at constant P. And now if P is constant means R by P is also constant value. So like this constant differentiation with respect to T is 0. So now you can see that dou m by dou y at constant x is equal to dou n by dou x at constant y. So z is a property. Clear hai? Z is a property, right? So this is all about thermodynamic properties. This is all about what? Thermodynamic properties. So the things which you have to remember about the thermodynamic property, that thermodynamic properties are the characteristics by which the system can be identified. The second thing, there are two type of thermodynamic property: intensive property and extensive property. Intensive property means independent of mass or size of the system, like pressure, temperature, density, etc. Extensive properties are that depend upon the mass or size of the system, like I can say volume, mass, energy, enthalpy, entropy. Now the ratio of two extensive properties are always intensive. The specific properties are always intensive properties. Properties do not depend upon the past history, right? And properties are the state functions or point functions. These are not path dependent. These properties are not depends upon the path. Clear hai? And then after that one more thing, that properties are exact differential. Exact differential means if z is the function of x and y, that can be written in form of dz is equal to m dx plus n dy. If z is the exact differential, then dou m by dou y at constant x is equal to dou n by dou x at constant y, right? So this example also I given. So this is all about thermodynamic property. Now how they may ask question? Very simple. They will give you 4 options, right? 4 options A, B, C, D will be given to you, and they will ask that which one is the property, which one is the property, or which one is not a property. Then you need to check for all the options. You need to check that which one is a intensive, or which one is a which one is a exact differential, or which one is a not exact differential. So this is all about thermodynamic properties. Now in next lecture, right, in next lecture we'll discuss about that thermodynamic equilibrium, thermodynamic processes, reversible process, irreversible process. So hopefully in 5th lecture, right, this is a 4th lecture, basically in 5th lecture the basic concepts, right, basic concept, basic definition part will be over, and after that we will start the most important concept of the thermodynamic, that is the properties of ideal and real gases, and the properties of mixture of ideal and real gases. Okay, thank you very much. Any confusion, please tell me. No? Yes, Ladani, yeah, tell me beta. Very good very good evening. If anyone wants to ask anything, please ask. If anyone wants to ask anything, please ask. If anyone wants to ask anything, please ask. Hello. If anyone wants to ask anything, any confusion in thermodynamic properties? No confusion? Chalo, thank you very much, and let's meet in a next class where we'll discuss about the thermodynamic equilibrium, thermodynamic processes, reversible process, irreversible process, everything, whatever is required for basic concept, that will cover in next class. Thank you very much.